Hi, hello viewers. Today we are going to see what is machine learning and where and all machine learning used and how we can learn machine learning. Okay, now let's see what is machine learning. If you didn't know what is machine learning, then you can watch our previous video AI World. In that we explained all the concept for machine learning and deep learning and natural language processing and computer vision. All this comes under artificial intelligence. Today we are going to see only about machine learning. So within machine learning, there are many subtopics like supervised learning, unsupervised learning, and semi-supervised learning, and reinforcement learning. Let's see one example for each category. For supervised learning, say for example, if you want to predict the price for the house, you have data like location and the number of rooms and square feet of the house. So based on that, you already have some price for that house. Similar way, you want to predict the house of another home that is having different square feet. In that situation, you can use your previous record, that is like you already have input and as well as output. This is not only like one data. Similar way, you might have multiple data. Say for example, one particular city you might have more than 10,000 data for different 10,000 house. Okay, based on that data you can predict the price of another 5,000 home. So like that, past data you can predict the price of the future home based on this all input parameter. So like that, you can use in supervised learning you have both input as well as output data, so that's why it is called supervised learning. But in case of unsupervised learning, you will be given only the input data. You need to find out what is the output. Okay, in that scenario, like example, like say for example, in particular city where and all COVID cases are there. Okay, they will give you the raw data of that particular city full population data. You need to find out the clusters where and all COVID is more. So once you find it, that one, you can say that particular zone is a red zone or green zone. So that end output you need to find it based on your input. So in supervised learning, only that input will be there. You need to find out the output. There will be no previous output for you to judge what will be your new output. Okay, in semi supervised learning it is kind of like you might have input data, sometime you might have output data also. So this particular case where they are using in GPS tracking whenever they want to find out the lane in the road. So in that kind of situation they are using semi-supervised learning. Regarding reinforcement learning is very good example is cycle riding. When we start riding a cycle, we don't know when we start newly, we might fall down. Okay, slowly we'll learn how we can ride the cycle. So like that, each and every time you will improve your cycling experience and finally you become better. So best example for reinforcement learning is driverless car nowadays. So without driver, car will automatically run using machine learning. So that is one very good example for reinforcement learning. Okay, now let's see what are the different machine learning algorithms. We are going to see only top 10 machine learning algorithms today. Within machine learning algorithm, we have different category like regression, classification, clustering. I'll give you one example for each category, like similar to our previous slide. Regression is mostly like you want to detect something based on your past data as well as present data. Example, that house price detection or stock market price detection. And classification is nothing but you want to classify things like whether you got a spam mail or not. Okay, or you want to classify some images like whether image is a cat or dog. Those kind of classification, or in some cases in banking and all, when we receive customer data, we want to find out whether this customer is a risky customer or a normal customer. Risky customer means based on their salary and their age and their previous record, we can judge whether we can able to give loan for this particular person. Okay, in that scenario bank will use a classification. for the customer data, whether the person is a risky customer or a normal customer. Within risk also there is like medium level or high level risk or a low level risk. So that kind of classification also we can do. Clustering is nothing but I told you in the previous example, like when you have raw data, you want to find out some clusters, like COVID cases and all. So that is a clustering. So for this three category, we have a different algorithm. First one is linear regression. Linear regression you can use mostly for regression, and for logistic regression you can use for classification. It is mostly like a binary classification, like detecting spam mail, whether mail is spam or non-spam, like that. Decision tree is like a multi-level classification, like I told the bank example, right? When we receive customer data, you can identify whether the person is a risky customer or the risk level is a medium or high or low. So those kind of multi-classification you can use a decision tree. But decision tree algorithm you can use for both regression as well as classification. Both the cases you can use. Random forest also you can use for both the cases. Then what is the difference between decision tree and random forest? Both are like comes under same category only. In decision tree, like it have different node, like branches. In each node we will consider different condition, whether why this customer is a risky customer because their age is more, or this customer is salary is very low, then we'll decide this customer is risky, or this customer location is something risky location, so we can consider this customer as risky. Based on this different condition, we'll check in different branches, then finally we conclude whether the customer is good or not. So based on that different condition, you are checking and classifying the customer data, right? In those scenarios you can use decision tree. But in random forest, similar to decision tree, you will have multiple decision tree, bunch of decision tree that will classify your data. Finally you will get the, like say for example you have 100 decision tree. Out of 100 decision tree, it is giving like 80 decision tree is going to give some data, okay, and remaining 20 is going to give some data. You will then random forest will try to get the best one out of that 100. So that will be like that 80 decision tree, whatever it is going to give output. So based on the machine learning algorithm itself, you can easily understand what kind of algorithm it is. Like I told, random forest means it is a bunch of decision tree. Decision tree is based on different nodes and branches. Linear regression, so you can understand the purpose of the each machine learning based on their name itself. Then finally, support vector machine. Support vector machine is also kind of classification. There we will be using some hyperlane. That hyperlane will classify your data. Same scenario, like your mail is spam or not, or your customer is a risky customer or not. So those kind of scenario also we can use support vector machine. And how we can decide which classification algorithm we can use, that is based on your data. If your data is regression data, then you can use linear regression. If your data is going to be classification, that is also only binary classification, either 0 or 1, in that time you can use logistical regression. If it is multi classification, you can go for decision tree. In multi classification also you need better accuracy, then you can choose a random forest. Support vector machine also, it is like kind of classification only, but it's purely based on your data type. We can choose all this algorithm. Now let's see remaining 5 machine learning algorithm. First one is gradient boosting algorithm. Boosting algorithm is mainly used whenever you want to increase the accuracy of the model. Say for example, you used the random forest for some classification. You got only 80% accuracy. If you want to improve the accuracy of the model better than 80, then that time you can use boosting algorithm. And next one is k nearest neighbor. This is the algorithm, it is used in Uber and Ola. Whenever you place a request for car, it will immediately check the bunch of car near to your location. In that time, nearest neighbor algorithm is used. And navy Bayes, it is mainly used for test classification. Say for example, when some person tweet something in Twitter, you want to understand that tweet is positive tweet or a negative one. So in that time you need to extract the test information from Twitter. then you need to convert that one as feature data using feature engineering. Then you need to classify that one whether this tweet is a positive one or a negative one. Okay. The next one is time series algorithm. It is very much used whenever if company want to forecast their revenue based on the years or based on the some date. In that time, you are using date, year as one of the parameter, and forecasting value it is in the revenue, it is in amount. It will be another parameter. In those kind of scenario, you can use the time series algorithm. In that we have different varieties, subtopic like sub algorithms like ARIMA, SARIMA. All these algorithms are available. And k-mean clustering, which we already discussed in a previous slide, like it is a good example for unsupervised learning. There they will be giving raw data, you need to find out the clusters. Okay, now let's see how we can develop machine learning models. Before we develop any machine learning model, what are the steps we need to follow? That we'll see one by one. First of all, you need to understand your problem statement. Say, for example, your companies need some particular problem statement. They are already facing some issue on particular use cases. Then focus on that particular use cases. Then find it out whether it's a regression problem or classification problem or or clustering, anything. Okay, any one of this might be there. So first identify the problem statement where your company need some focus, and they can use that one and generate some revenue. Okay, find out that problem. Then once you find out that one, discuss that one with your business partner and whoever have authority to approve that use case. Okay, this is very good use case. Okay, then get all their approval. After that, then you think about how we can collect the data for this particular use case. Do you have already any big data system, or do you have already any data lake which is already having this kind of data? So think about collecting data from those source system. Then after that, you need to think about your data, whether it's structural data or unstructured data. If you are collecting from data lake or big data, sometimes you need to do unstructured to structure format. That time you need to use feature engineering and the data processing steps. Or sometimes you, if you are receiving the data from Twitter or some website, you need to do web scraping, then convert your unstructured data into structure. All that steps you need to do using feature engineering only. In feature engineering, you need to do data cleaning, like removing null values, and if you're thinking like some of the column is not going to be useful for your regression or classification, you can remove that columns. Also, you think like some of the data it is not going to be useful for your model development, then you can remove those data. That will be called as outliers. Okay, so like that you can do a lot of feature engineering. And if you are having like more columns, like for house price prediction, say for example I told you only location and square feet and number of room, but in actual scenario you might have different other column also which is might not needed for your price prediction. In those scenario you can remove those column also in feature engineering and use only the column which is needed for your price deduction. Okay, so like that you can do feature engineering. Then once you finalized your feature engineering step, after that you need to split your entire data into train and test data. Train is like using train data only you are going to train your machine learning model. Once model is trained with your trained data, then you can give some input data, that is kind of test data. Then you can see the output. Normally people split the entire data like 80-20. Some people do 70-30 also. 80-20 means 80% of trained data, 20% of test data. 70-30 means 70% of trained data and 30% of test data. Okay, so in house price prediction, you can give 70% of your previous house prices, and you can give some input like 30% as a test data without any price target value. In that time, what will happen? You can predict the price of that 30% of house using your trained data that was already given as input to the model. In machine learning, like whatever data you give, according to only machine will give you the output. If you give proper fine-tuned feature data, it will give you better accuracy. In case if you give any garbage data, your accuracy also will be like not better, might be it will be also like garbage only. Okay, so always give better fine-tuned data using feature engineering, then you will see very good accuracy. Okay, once you split the data, train and test data, you can use this train data into the fit method of the algorithm. If you are using scikit-learn or TensorFlow or Spark based library, there will be some method called fit method for each algorithm. In that you can fit your train data. There will be one more method called predict. Using that predict method, you can predict your test data. Okay, this will be there in all the framework: scikit-learn, TensorFlow, Spark, everything. And accuracy score is nothing but you can check your model output, how much accuracy you got it end of the model development. For regression, there is some metrics they are using, like root mean square value, and confusion matrix is used for classification. And for clustering, there is some metrics we can use, we can compare two clusters and find out the accuracy. I hope this video is useful for you. Hope you learned machine learning and what are the different machine learning algorithm. If you like this video, please like, comment, share and subscribe. Thank you.